Recording. Hi. Alright, so ladies and gentlemen, here's the topic of today's lesson. We're going to talk about surface area, and I will have to talk a little bit louder because I want to make sure that the camera picks up my voice. Surface area of two particular shapes. Prisms, and right cylinders. So let's take a look at the warm-up. This goes together with what we learned in 10.1. So by now, I would expect that you can make a connection between a three-dimensional shape and a two-dimensional net. So your job right now is to tell me what type of a three-dimensional shape you would be able to construct with this net. Don't say it, just make a sketch, write the name of it. Remember that the name has to describe the base. Not only tell what shape it is, but tell me or tell everyone what type of a base we have. Okay, who is courageous enough to go to the board and make a sketch? Artistic people. I know we have artistic people in this group. She's not here today. Okay, well, I'm going to pick an artist. Mira, come
I
here.
can't draw.
Yes, you can.
No, I can
Try
try.
it, please.
I can't.
Well, I'm sure you will do a wonderful
Wait, which
job.
one I draw? That.
Uh,
I can't draw that.
what do you think it's going to be?
A triangular prism.
Yes, good. So write in triangular prism with something that actually does work. Let's try this one. What's the best way to sketch a triangular prism? Let's help her out. Shreya.
A triangle and
Okay, she's helping you. I will just tweak your answer a little bit. I wouldn't say the thingy. How do we call it the thingy?
a triangle.
Triangle, but what is it? What part of the prism is that?
The base.
The base, thank you. So start with the bases.
So, with that, right?
That's perfect.
It's too
Okay,
And then you same.
connect the corresponding vertices, right?
Right?
Wow,
Yeah, and
look
she-
at you. Look at you.
Thank you. Now, I'll just tell you, because I have to be 100% correct, the edges that we cannot see with our eyes should be dashed. Or dotted. So, what else? This one and
The
And the
back
the back one? Okay.
line.
Good.
what about the-
Perfect. Yeah, the one up. The other.
in the back?
Oh, yeah. Great. Do you feel more comfortable with working with the nets? All right, let me show you examples of prisms and what's the other shape? Cylinders that you can come across in real life. So not only in geometry, but in our surrounding world. And we talked about some of them before. You will know which one I have in mind because you actually gave me that idea. But before I show you the pictures, I just want to briefly introduce the objectives. I want you to be able to calculate the surface area of prisms and cylinders, right prisms and right cylinders. And I don't know if we're going to get to the last objective, but either today at the end of the hour or Monday at the beginning, we're going to learn how to find the missing dimensions when we know the surface area. So those are the algebraic problems that we all love to solve. Have you ever seen this?
Yeah.
Yeah. Oh, what happens when the light goes through triangular prism? I? Well, something happens with it, right? When it enters the prism, what is the color of the light? White. And when it exits,
Different color.
so it splits the color. And the same thing happens in nature. The raindrops kind of work the same way as triangular prisms. They split the light into these colors, and we know we know what this is, right? Okay, what about that? It is a house. It's actually interesting because I didn't pay attention to the details, but if you look closely, that's a garage, I think.
What?
That is
Two cars. What type of shape is it? Rectangular prisms. I don't know, it's very interesting, very modern
That's
looking.
code.
Invisible.
Well, big windows, that's for sure.
Everybody's seeing it.
Well, I went from something sophisticated to rather simple.
I know.
A piece of wood is also considered a prism, rectangular prism. This is interesting. This is actually not man-made. These are rock formations, and I think you can see them on the coast of Ireland. So look at the tops. They kind of look like polygons, right? Pentagons and hexagons. And then the rest of it kind of looks like a prism. Okay, this is a piece of cheese in the shape of a cylinder. What are these? Cylinders. I'm sure you've seen those in the countryside. What do we use them for?
Storing corn.
Storing corn. Okay. And here's your example from yesterday.
Leaning Tower of Pisa.
Leaning Tower of Pisa.
Where's that at?
In Italy. And speaking of that, here's the author.
Oh,
We were just talking
I'm
about
gonna speak. Check it out to see.
Now this is of course not a perfect cylinder, but it's definitely has that shape. There you go. I'll take it. Okay, so what do we know about right prisms? Maybe we should concentrate on the word right first. Why is this called a right prism?
It's
Between?
the bases and the light.
Thank you. If you look at what, I know this was perfect. Okay, so let's put this here. So the height, which by the way is called an altitude sometimes. I don't know if I can spell it, I think I can. Is perpendicular . I knew I would. Altitude. Altitude is perpendicular to the basis. You know, there was a reason why I stopped there. Altitude.
I'm not gonna look at on camera.
Altitude. Okay. Now everybody will remember, altitude is perpendicular. Alright folks, what else do we know? What makes this different from a cylinder? Let's just talk about similarities and differences.
It has sides.
It has sides. Okay, let's elaborate on it. Has vertices, good. Has edges. How many bases do we have?
2.
What can you tell me about those bases?
They're polygons.
Let's put that information down. So bases are polygons. Are they the same? Are they different? What's the spatial relationship between them?
They're congruent and parallel.
Okay, congruent and parallel. What about the other sides? Not the bases, but the sides.
Lateral.
Lateral sides, what are they?
Bases.
Rectangles, good. So lateral faces. put down what Lisa mentioned, that we have vertices and edges. Now take a moment and see if you can list all the properties of a right cylinder. We're actually going to save some time. And instead of writing them again, tell me which ones I should erase or how should I change these. So let's start with the first one. The altitude is perpendicular to the base. Is that still true?
Yes.
Yeah.
Okay, well, let's show it. Now we may have to finish the circle here on the bottom. Okay, so that's true, so that stays. The bases are polygons. Max,
Change that to circle.
circle, so we're going to erase this. And, whoops, missed that completely. Lateral faces are rectangles. Well,
If you
I think I know what you mean. Is it a flat surface or is it a curved surface?
Curved.
Okay, and do we have more than one? Yes, no? One. So we have to change that, and instead of faces, just put down that the lateral face is curved.
So it's only one lateral face.
Yes. Because remember, if I'm going to refresh your memory a little bit, and I have one cone that is kind of falling apart. It's not a cone, it's a cylinder. I have one cylinder that is kind of falling apart, so I'm just going to demolish it. Okay? So look, when I take it apart, right, this is the curved surface. What am I getting? Rectangle. Well, why don't we put a rectangle when unfolded? And what should we do with the last statement? Do we have vertices? Do we have edges?
No.
Remember, edge is a straight segment, line segment. So you're shaking your heads, I'm assuming that's a no? Is there anything else that you would like to add?
No
To this
edges
list.
or vertices.
Instead of erasing, you can just put no edges, no vertices, or we can emphasize that fact by saying no edges, no vertices. And before we move on to the group activity, I want us to remind ourselves what the surface area is. So I think it's easier to do it when you're comparing it to volume. So who can tell me the difference again? What is the surface area versus what is the volume? Anybody? Lisa?
Is the surface area the area of the base and volume is the area of the inside?
I like what you said about the inside. I think the volume refers to the inside. And the surface area, I would refer to the outside of the shape. but I would have mixed up the volume and the area. So volume has nothing to do with the area of the inside. Anybody else?
Volume is like how much you can fit in a shape, and subsidiary how much you want to wrap around.
Okay, good. So the surface area refers to the outside, right? I'm going to use a specific example. The area you can cover with paper, for instance. Would that make sense to you? And then in parentheses, why don't we make a statement about volume, just to have some contrast. The volume would be how much you can fill in or put inside. How about we use sand? Now you do realize that these are just examples, you know. You can pour liquid inside a three-dimensional shape, but I think it helps us distinguish, tell apart the two concepts. Okay. I want us to look at the other handout, the one that, the packet. And go to page number 3. I will have you work on the other two in groups in just a moment, but as I learned today, it might be beneficial for us to go through one of these together, just so you understand what needs to be done. Max, do me a favor, please, and read the problem, so we know what we're dealing with, what situation we're dealing with.
Todd is creating a pop art masterpiece. The piece that he is working on is a cylinder with a radius of 20 inches and a height of 40 inches. Todd wants to cover the outside surface of the cylinder with mosaic tiles. How many square inches of the mosaic will Todd need to complete that?
Okay, so now we're going to read it as if this was a mystery novel, with passion. You can do it. Max, try it again.
No.
Go for it.
You do it.
I'll get you started. Todd is creating a pop art masterpiece. Who's going to read the second sentence? Come on.
Hello.
Thank you, America.
The piece that he is working on is a cylinder with the radius of 20 inches and the height of 40 inches.
Wonderful. I mean, this is silly, but what we're doing, we're actually paying attention to every single sentence, and we're spacing out the words so that our brains are processing the information better. I want you to go back to those two sentences and underline or highlight what do you think is mathematically important. Emeka, would you mind reading the next sentence?
Okay. Todd wants to cover the outside surface of the cylinder with mosaic tiles.
Okay, what is the key phrase here?
Outside.
Outside the surface area. Because if the problem was asking about the volume, you better pick that up, right? Otherwise you're solving the problem incorrectly. Max, you read it correctly. I'm just, trying to emphasize the important pieces. Amanda.
How many square inches of the mosaic will Todd need to complete the project?
All right. What is important in this question?
Okay.
Square inches.
Okay, thank you.
Oh.
Okay. Square inches, so underline that. That's the unit of measurements we're supposed to use. What else? It's a cylinder, all right, so we need to pay attention to the type of a shape. Max.
The radius is 20 inches.
Sorry, that's me. The radius is 20 inches.
The height is 40 inches.
Okay, so put that down somewhere on the side. That's important. So we have radius of 20 inches. You can even put a little r above it in the text. And this is the height. We have a cylinder, right? And we're looking for the surface. The unit of measurement is square inches. In part A, they're asking us to draw a diagram of the cylinder and as a two-dimensional net. So we have to imagine that we're taking something like this and we're taking it apart. Not so easy when you have tape attached to it. Now ignore these little pieces, connecting pieces. What do we have? And two circles. Alright, so make, to the best of your ability, I know this is not going to be perfect, but we have two circles connected to the same rectangle on the opposite sides.
Is it okay if I put the circles on right here?
I'm sorry,
Is it okay?
let me see.
No, it's,
I'm not sure if this is broad enough. Can somebody please label the sides of the... Okay. What is important about this shape? What dimensions? The height. Where's the height? Which edge is the height? The
From
side.
the circle.
How many inches?
40.
40. And then what else?
Radius is 20.
Now I'm going to do some magic. Color coding magic.
God.
Okay. Okay, what are the circles? Wow. Now, what's going to happen, or what other edge is matching this circumference of a circle?
The edge that's touching the circle.
Thank you. Ooh, how do we call that red? I don't want to name it because I'm going to give it away. Circumference. What is the formula for the circumference of a circle? 2 pi r. Excellent. So 2 pi r. So it happens to be that 2 pi r is the circumference of a circle, but it's also the length of the rectangle.
Yeah, that's true.
And the height is the width of the triangle. Alright, so now, we have to figure out how much paper, was it? We need to cover these three mosaic, okay, tiles. How much tiles in terms of surface area we need for these three surfaces. So how do we go about calculating the area of each piece and then the whole thing together? Do we need circumference of a circle?
Area.
The area, okay, so we're going to find the area of a circle. We can use symbols if we want to. How many of those circles do you have? 2. So when you find that, you're going to multiply that by 2, correct? And then add to it,
The
Length.
area of the square.
so the area of a rectangle. Now,
Is that a plus sign?
that's a plus sign, which looks really sloppy. Better. Okay, so ladies and gentlemen, what is the formula for the area of a circle?
R squared
Pi r squared, but we're going to multiply it by 2, because we have 2 circles. So 2 times pi r squared rectangle. Length times width, which in this case would be,
40 times 2 pi r.
how about I use h for a moment. So h times
2 pi.
2 pi r.
So,
Now let's plug in the numbers, and I want you to multiply it out completely. So don't leave the answer in terms of pi. Round it, couldn't use 100, I'm going to give you a moment to do it, and then you are welcome to take the calculator. Let me know. Yep. Area of the circle multiplied by 2 plus, right, the area of the rectangle
So is it the same of
for every single cylinder, yes. All right, folks. Let's just first verify that we have the same answer for this part here. So what is 2 times radius squared times pi?
2,513.27.
Okay, wonderful. I really want everyone to see, so I'm going to move it up here. 2,513.27 plus, now let's multiply these out. So 40 times 2 times pi times 20. What did you get?
1,026.47.
What is it?
5.
5. Thank you. So when we add these two quantities together, we are going to arrive at the final answer of, yes, thank you, okay. 7,539.82 if I, okay? Alright, so was this fairly clear? Do you have any questions? Yes.
How do you find the area of the rectangle? Because I don't know the base, we don't know the height of it.
The base is the same as circumference of the circle.
Oh, okay.
So that's actually an excellent question. What do you need to know to find the surface area of the rectangle?
The height?
You need to know the height, and you need to know the either the diameter or the radius, because it's 2 times r. So, all right. So here's what I want you to do. I'm going to display. Let me go back to the PowerPoint. I'm going to display a few formulas without telling you what shapes they go with. if I can make this move, actually. Well, I'm going to do it in a moment. So I'm going to show you 4 formulas. You are going to, when I say go, you're going to get together with your groups. And you're going to work on the first and the second problem. The first one has a rectangular prism, so read the problem just like we did with this one. Underline the key phrases, the most important parts of the problem, mathematically significant facts. And then draw the net, figure out the strategy for finding the total surface area, and please do not forget to answer the question that was stated in the problem, okay? Alright, so go. Work with your groups for the next 10, maybe 15 minutes. 1 and 2, okay? So take a moment now and get together with your groups. Turn the tables so you can see each other. Anybody would like to make the life easier for the group and tell me what these go with?
Oh.
This one is a triangle?
The first one is a rectangle.
How's that for confusing people, a circle and a triangle? This one is for?
Rectangle. Circle and then circumference.
You can come work with us if you want.
I'm good.
So,
Now, this is what circle, what area. What was the word that I misspelled? The
Altitude.
Oh, I think I'm just getting old. I don't remember what circumference means. Can somebody please remind me?
The perimeter of the circle.
Perimeter of the circle, this is around. Thank you. Alright, so work for the next 10 minutes.
So you gotta say one.
It's easier if you label
New
the edges. So we can
That looks like new.
over this net. Yeah. So all of the ones that are 6 labels. Boom.
Oh.
I didn't see that as that. So it's drawing that out.
Okay, so are we labeling all the edges of the net? Right? Yes, it's helpful.
Tim?
Reupholster. Take things off.
I know, but I kind of forget it, right? It is, you know, unfortunately, we don't have big tables. Last year I had a science classroom, and those huge, long tables, not the only disadvantage of that is that you cannot move them. You kind of are stuck, and the classroom is long, so it's hard to hear.
You spell prism.
Wow.
Big print.
Oh,
Rectangular
no,
print.
it's all to do. Okay, so all on three, 6 units, right? 6, 7, Look at it.
What?
That's
So what, yeah, what other edges go before?
Oh. Oh,
Wait,
that's
come on.
big.
I'm going to give you a little bit. The ones that are parallel to each other have the same length. So, what is parallel? Yeah.
Did you just say
Now, why do we care about that? Because now we can look at each part separately.
Hey,
And look at multiply length times width, right? And find the area of each piece. So this is 4. Once we know the area of each piece. Yeah. What do we have to do to get the area of each piece? Oh, this is 3.
Why'd you do that?
I had a little understand.
Even I'm
Okay.
You know what I would say, but I'm not going to. Can we have now brain spasms?
Well, let's read it.
No, it's this.
So,
Yeah.
to
Okay, I was talking
You guys use the same formula, that one.
with prisms. The edges that are parallel have the same length. Yeah,
Oh.
that is very helpful.
You choose.
Where's the mic from?
Well, he needs to make this.
Or does it not
Okay,
matter?
Okay, so let's concentrate on, I just
Okay,
picked
this is
something
gonna be a
off.
base.
Okay, so let's concentrate on one.
Okay,
So this is the
what is it?
shape, okay? That edge is 6 units long, right? What is that one? What's the length of that one?
This is your side.
So now all of the ones that are parallel to this one, so they're all 4, it's 9, right? So what is 3?
Well,
Can you pop up kind of the ones with? How are you doing?
This is-
That's wrong.
We have to add all of the widths together.
And like Liam said, all of these will be 6.
Oh,
The ones that are parallel to each other are the same length, right?
yes, that would be 6. This is 6.
So it's the area of the bases times 2. And the area of the base times 2.
4 is
This is the side that's
Now, I was telling the other group that it's always nice to pick one side as a reference, so this is how we
That's
know.
all.
Alright? That's
Oh,
not
you just do it square.
How it
And then for the
You probably want to do
pretty much. What? What?
Alright, so I want you guys to read about,
Look at them on.
oh, you just take, yeah. No, yeah.
Not mine.
Oh, yeah.
Hello?
Close?
That's great.
Something needs to be tweaked. I really want you to go around the shape and find the.
So,
It's a fly.
It's a
last time it was B and it got crazy.
Oh yeah, remember the
It
first
was
day?
being cut.
That was
It got worse this year.
Alright?
There's a fine. There's a fine.
Sorry.
Or a bug.
That wasn't the first before.
What if you like land on the candle end?
Yeah, you
Just
said that
like,
was-
and then we saw it. That's funny.
It wasn't thought. It wasn't, right? Okay, so where are we in terms of this problem?
Okay, so you do 4 times.
Right? Yes, here's what I do. I just make it really simple for myself because I'm visual, so formulas work for me. But if I can see a picture, even better. I look at each and every single shape, and I try to figure out the formula, the area. So what is the area of the shade that I want?
You're sleeping?
What is it? Put 24 in a circle inside the shape.
Oh, no.
Do that for every single.
Why do they only have green and red?
Okay. So now look at each rectangle.
I don't like that language in this class.
Okay, now.
Just say shut up.
Okay. But does it really matter?
Mr. Schumann.
You must like it, right?
Yeah.
So it's nice to know, but mathematically you're going to get the same answer, regardless of how or in what order.
Lisa, put away your phone.
So what would be the surface area of this rectangle?
No.
Put 24 in a circle inside the shape. Well, inside. So 24. So you know this
Everyone
one.
has slides.
And then do that for all the other ones.
You're like way stronger than me.
Okay, so the answer to that
Fix the fun fight.
sleepy kid.
Yeah. Yep. No.
I
Let's think
think
about
mine
it.
is weird.
I can actually see.
We can,
It's like that.
can we, my question, figure out the total surface area at this moment? That's fine.
I
So, you, this is 4, this is 6.
Why did you give the areas from the
And then go ahead by 4. There's 4. Okay, so then this is 4 here, and then 12, and then 12 here.
I don't see that work
Yeah,
out. So you find
and you do have the right formula. Did you see it? How did your develop it?
My tick marks inside the circle. That's just
Alright, so now pay attention here to correctly labeled this as 4.6. Oh, you find the look arrow, that's not. And the triangle is fine, surface area.
How he was, like, so tense stuff. Yeah.
So really,
No one is commenting. Oh, wait, I lost
and you get this. Okay, you need to move on to the triangle.
Yeah.
Okay, now let's start with drawing the next. Which is kind of like your warm-up, so good thing.
Thank you.
And so it's
formerly Oleo.
Yes, oh, we're missing one side. If you were to make a 3D shape out of this, would that be completely presented or actually in that? Yeah, you need a lid. See, this is the bottom, right? These are the sides. Yeah. They're really good. But you don't have it. We have it attached to the other rectangle. Okay.
Straight away, check. Oh.
wow.
It's about 4 seconds.
Okay. Alright, so I'm going to come back to you. I want you to label all the edges of that net because that's the key. Yes.
Okay.
Okay, so 12.6, that's all I have so far.
Oh, this is 7. Wait, this is 7, right?
Doing work, so I
Technically, we have no choice. No, I need to see what they're. Yeah. It has to be, okay, the lid bottom are kind of parallel, right?
congruent.
And they have the same dimensions.
So,
No.
So.
how do you find the area of that?
Where is that one?
Yeah.
So the answer is yes.
Also, so you
Yeah, okay. So then, and then you wanna add it together with each hour.
Wait, how is that?
How to find the area of both.
These edges?
Yeah.
Because the
Okay,
rest
so.
is trying to.
Because we just this.
Oh, yeah.
Raised by. Yeah, so let's do two
You can
times
use
one
that.
times
Alright, Nadia is working on a project for
two times one times. And then you just do the same thing.
She's back.
Because this is way wide.
Because.
This is visual.
Are congruent.
I only take one side.
These two are congruent.
Wait, these are warm. So, what according to your application, how is that?
It would be like a tub.
Oh, yeah, oh, wait, so we just
if
put
I
that
don't know,
over
I
here.
get points too, so.
So annoying.
It's like,
Hey, that would make sense. Okay, so you can do,
and then, yeah, that was like way too
two
late.
times one times.
If you try and.
So those are the.
Seven, yes.
That are congruent.
What was that?
They're supposed to use two like this and then.
Okay, so
You have the same tables for all.
So wait.
The numbers you use.
Yeah.
So.
No, you don't do it.
You have to figure out
I like mine.
You gotta like. I put
Lot of cream.
Alright, so,
Lot of cream.
alright, so
Because that
I think
has
we're
to
ready
be
to calculate the area of every single piece.
This right here.
Yeah, start with the triangles because those are the highest ones.
Three.
Yeah. So what are we doing? What's the formula of the area?
What ways?
So,
we need to add, yes.
24/7? Yeah, I know. It's.
I don't get that, no.
That teaches good.
Wait, yeah. Also, this is 3.
Ready?
So that's what yes. So the height of the triangle is 9.5. So you do 3.5 times 3. Half of that. Yeah, yes. Times 2. Alright, go for it.
Oh, it depends on the way. Yeah, okay. No, this is 4. You put these in the same. That was one that's 4.
Well, hold on, how many bases do we need?
And then
Multiply that figure by
So we have these one and these five. These five are equal to each other, so both of these
And then
four.
you just have to figure out the area of the
So
three
then
rectangles that
you
make
just
lateral
do 3
faces.
times 6 for this one times 2.
Find the,
you
remember how
got
the areas of the two.
And then
So
these
now you have to find the area of those 3 rectangles.
3 times 4 times 2.
Once we have all of them, we can.
And then you do 6 times 4.
You did 4.6 on the side of the triangle.
Yeah.
And then 21 times
So which, if you can inside how they were pointing right here, that's the inside of the base, so that's why I put it right there.
What do you mean?
Yeah, did you get that?
So I think it's how to go right there because this is the
Triangle.
inside.
I think all should still be pointing to the height of the side.
A little bit. Yeah. Oh, I see.
Would you like me to?
Yeah, take that one. Can you please come over and instruct me? Show me. No. See, we started off like that. Well, mine is. I got the pen in there.
They're parallel.
Oh, well.
So how quickly we'll find or why?
Let me just redraw this real quick. Let me just crop thought they were gonna draw. I said next one. My house.
You got something.
Thank you, Angela.
What are you taking?
That's her.
No, I've been.
This is for Sue right here. Will I am. That's what I am. Oh,
Alright, folks, if I can have your attention because we need to be aware of the time. You have a couple more minutes to wrap everything up. I'm not assigning any homework from the book. I didn't say I'm not giving any homework. Now, the homework that I'm giving you this weekend is a little different, and it may require using your phone. Here's what I want you to do, yes. I want you to take a picture of an object that looks like a rectangular, triangular prism or a cylinder. Okay? If you don't have a phone, that's okay. You can just find a picture in a magazine or on the internet and bring it with you. But you should be ready to present it. So it's kind of like show and tell.
What?
And so that's for Monday. Please finish this on your own because we are going to start the class period on Monday with your presentations. You will come and you will teach the class.
No, man, come on.
Now, it's gonna be.
No, we have left for her class.